Let's talk about non-employment immigration history. In 1970, the U.S. Congress added an amendment to multinational American firms. In years to come, this was split into two separate subcategories: a 7-year period for executives and...
Immigration employment?
You said we were doing a video on L1A.
This is astronomy class, not socials. I said Aditya L-1, the space probe, not L1A immigration.
Oh, shit! Let me take you back. 1957. You're sitting in your presidential office when your assistant bursts in the door.
Sir, those dirty Soviets, they did it!
What is it, Summersby?
They did it! They put us
Satellite.
under space!
While I believe the actual transfer of events probably had a couple more profanities than this reenactment, I think this is almost exactly how Dwight D. Eisenhower reacted to this information being passed down to him on October 4th, 1957, the start of the space race. The US would respond to this news by launching their own satellite in 1958 and the creation of NASA. The battle kept growing as the Soviets were the first to hit the moon with a probe and the first to have a man orbit around the Earth. But of course, July 20th, 1969, the US put a man on the moon. After this massive event, American interest in lunar missions started to wane. Today, a large portion of major countries have put probes and doodads up in space, but when talking space, there's really only the big five. There's the Americans, with the most famous space program in the world. There's Russia, who were the Soviets during the space race. And then there's the Europeans, which, okay, that isn't really a country, but like their space program has made an impact, so we'll count them. China, who has made significant progress in the past 2 decades. And finally, India. The Indian Space Research Organization, or IRSO, was made in 1969 in replacement for the previous space organization. In years to come, India would make another department for space research and move it under its umbrella. In 1975, India launched its first ever satellite, the Aryabhata, which was the start of a satellite communication system that would help hundreds of thousands of Indians. In the 80s, the IRSO, I'm just going to start calling it IRSO, it's easier, made pioneering efforts in remote sensing technology. In the 90s, they created the Indian Remote Satellite Sensing System and the Polar Satellite Launch Vehicle. Then around comes 2023, and IRSO, for whatever reason, either for scientific research or because they were bored out of their minds, who really knows, decided to try something new. They set out to perform their first ever solar mission. And that's exactly what they did. On September 2nd, 2023, the successful launch of the Aditya L-1 Space Observatory took place and commenced on its journey to its final destination, Lagrange Point 1. That's it. Thank you for watching. I hope you had a good time. Goodbye.
Matthew!
What? Okay, so it's been brought to my attention that I should explain the mission of Aditya L-1 and what a Lagrange point is. A Lagrange point is an area where the gravitational force of two celestial bodies will cancel out and create an area where a spacecraft can be sent that, with its orbital motion, will cancel out due to the force of both the Earth and the Sun pulling upon it, creating an area of holding. Ships that make it to the Lagrange points need propellant in order to stay in its orbit. However, the amount of fuel they use is less than it would sitting out in open space, which makes these more fuel efficient. Another benefit of these ships that make it to Lagrange points is constant observation. By being out in open space, they can keep a complete and unobstructed eye on whatever they are studying. Unlike a probe in orbit, which can only observe for an allotted time until whatever they are observing is hidden behind the celestial body they are orbiting. Not to mention, these points also rotate with the Earth because of the rotation around the Sun. In relation to the Sun and the Earth, there are 5 Lagrange points, L1 being the closest at about 1.5 million kilometers away, and L2 being second. Some other notable observatories that have been sent to L1 include the SOHO Observatory, which was a joint effort between NASA and the European Space Agency, and at L2, the James Webb Telescope, which is responsible for some of these absolutely stunning images. In fact, its placement at L2 is the reason it can get all these images. But that's a story for another time. Jack. We're all about L1 over here. So, now that you hopefully understand what a Lagrange point is, let's talk about Aditya L1's actual mission. Simply put, Aditya L-1's mission is to study the three topmost layers of the sun: the photosphere, chromosphere, and corona, and the relation between them. For context, the photosphere is the coldest part of the sun, and often referred to as the lowest part of its atmosphere. It is usually sitting around 5,500 degrees Celsius and is commonly referred to as the surface of the sun, even though it doesn't really have one. The layer above this is the chromosphere, where the temperature begins to rise again to 6,000 to 20,000 degrees Celsius-ish. After a short transition area, we get to... I like it here. The corona, where we can find insanely hot plasma that can get from 1 million to 3 million degrees Celsius. Now, people, I don't know if you realize this. We are talking young Leonardo DiCaprio levels of hot, okay? I need you to understand that. Now, while it is not known why this phenomenon of heating up as it gets closer to the outside occurs, scientists do have their theories. And it's thought that maybe Aditya can provide some context and adequate answers as to why this does happen. Along with this, it will be studying the dynamics of the origins of coronal mass ejections and multiple other things that are listed on the IROS website, which is down in the description. Okay, so we know what we're researching. We know where we're researching it. The next question is how? How do we get this research done? Aditya L-1 is going to be 1% of the distance from Earth to the Sun. How do we get this information? It all relies on carcinogens. Yes, cancer. Well, kind of. Okay, not really, but it relies on one thing that causes cancer, okay? The sun produces many different levels of electromagnetic radiation. Ultraviolet rays, or UV rays, which cause skin cancer. And then there's infrared, gamma rays, X-rays, radio waves, and solar wind, which is a charged wave of protons and electrons. So, what does Aditya do with all these? Glad you asked, because it has 7 different payloads on board that it uses to measure all these. Firstly, we have the VELC, or, as other people would call it, the Visible Emission Line Coronagraph. Firstly, we have the VELC, which is also known as the Visible Emission Line Coronagraph, which will be solely focused on the corona and coronal mass ejections. Second, SOOT, or the Solar Ultraviolet Imaging Telescope, which will be taking images of the sun's chromosphere and photosphere at ultraviolet levels. Third, SOLEXIS, or Solar Low Energy X-ray Spectrometer, and fourth, High Energy L-1 Orbiting X-ray Spectrometer, or HELIOS, which are both tasked with analyzing the X-rays produced from the sun, especially solar flares. Fifth, Aspects, and sixth, PAPA, will work to study particles from solar wind. And finally, seventh, MAG, a magnometer to study the magnetic fields in space. Helios, SOOT, SOLEXIS, and VELC will be used to actually study the sun. Meanwhile, the remaining 3 payloads will all be tasked with studying everything around the L1 orbit. And just like that, info dump done. Now time for a visual representation of what's happened so far.
Well, gosh golly, that's a problem.
We've got another one in the closet.
One eternity later.
Time for a visual representation. As I stated before, on September 2nd, 2023, Aditya L-1 left Earth's surface and got to the atmosphere. It then performed 5 maneuvers to gain the velocity it needed and set off on its 4-month journey to Lagrange Point 1. On September 18th, it started its collection of data. On September 30th, it escaped the sphere of Earth's influence. October 8th brought some minor adjustments to Aditya's trajectory. Then, on November 7th, 2023, Helios captured the first look at high-energy X-rays from the sun. December 1st, Aspects goes operational. On December 8th, the SOOT payload captured ultraviolet images on multiple wavelengths. And on January 6th, 2024, it was successfully maneuvered into L1 orbit where it sits today. Since then, the VELC payload has been able to precisely show and predict where a coronal mass ejection starts and what direction it's going. If you want to read about all that Aditya L-1 has collected data-wise, I'm leaving a link to the IROS website in the description. Aditya L-1's planned mission time is about 5 years, and at the time of writing this script, it's been 1 year and 39 days since its arrival at the L1 point. Thank you for listening to me ramble about this space observatory for... I don't know how long. I've been recording for 3 hours. I don't know how much I'm actually going to get out of this video. From all of us here at Stiff Baguette Studios, I'm Matthew Evans. You stay classy, San Diego.